All right, really, I gotta make this video for you, but I know it's been a long time and I'm happy to make this video for you to kind of bring back some of those memories, hopefully of, I don't know, working on long division and trying to be like, oh my God, this is the longest process ever compared to adding and multiplying. And back in the day when you first learned it, you were correct. So what I want to do is I just want to go through a quick example of long division, and then I'm going to kind of discuss how that applies to polynomials. So let's take a look at, I want to take 8 and divide it into 1,856. So what we're going to do is we're going to say, does 8 divide into 1,856? Now, remember that we have certain names for these, and I'm going to be using these a while, so it's important for us to understand them. The term that we're going to divide into is called our dividend, and the number that we're dividing into is our dividend. The number we're going to use to divide into is our divisor. Our answer is going to be our quotient. And if there's anything extra, we call that the remainder. So what we're going to do is the first thing you want to do is to break this up is just to see, does your term first divide into your first term? And since 8 does not divide into 1, I move on to the next two terms. I look at now the next two spots is 8 divided into 18, and yes, it does. It goes in there twice. So I'm going to put a 2 over my 18, and then I multiply 2 times 8, which is going to give me 16. Now, when you're doing long division, you want to make sure that you subtract your two rows. So 18 minus 16 is 2. Now, does 8 go into 2? No, so I'm going to drop down the next number, which will be 5. Does 8 go into 25? Yes, it does. It goes in there 3 times. Then I multiply 3 times 8, which is going to give me 24. Now, again, I subtract the rows, and what that's going to give me is 1. 8 does not go into 1, so I drop down the 6. Does 8 go into 16? Yes, it goes in there twice. Multiply 2 times 8 is going to be 16. Subtract 0. So therefore, my quotient is going to be 232, which is the answer, and my remainder is going to be 0. Now, why do we really care about this as far as, polynomials? Well, here's what I want to understand. Here's what I want to get with you about the long division process, or even just division in general. When I say 8 divided into 1,856, right, that tells me that 8 evenly, since we have a remainder of 0, 8 evenly divides into my number. Also, it divides into it by 232 times, right? So therefore, what I can say is 8 and 232 are both factors of my number 1,856. And if you remember in polynomials, we've talked a lot about factors, right? We've talked about taking a polynomial and then factoring it down to its factors. Well, how do we determine if a factor is actually a factor of a polynomial? We can do that by applying long division. If you apply long division with maybe let's say you're given a factor. If you're given a factor and you factor and you see if you can divide it by long division into your polynomial, and if it goes in there even with the remainder 0, then you know that it's the divisor and the quotient are both factors. And why do we care if they're factors or not of a polynomial? Because once you know you have your factor, you can find the zeros. And that's going to be the important thing that we're looking into, is finding our zeros of our polynomial. So here's the process for long division. I'm going to have plenty of videos so you can go and check them out over on the site about how actually to do it with polynomials. But I hope you enjoyed. If you had any general questions, please make sure you just comment below. Thanks.